Hello all, I am Debabrata, research scholar at IIT Bombay, India, also working at Honeywell Aerospace. My co-authors are Shirsha from TUM University, Professor Biplab from IIT Bombay, Dr. Yogananda from Honeywell. Together, we will be presenting you today a novel fine-grained few-shot open-set recognition framework, MORGAN. In case of hyperspectral datasets, there exist lot of unannotated black pixels, and a closed-set trained model, whenever encountered these pixels, they often get misclassified to one of the known classes. Also, existing FSOSR methods either try to amplify the data density of the known classes or the open space. It creates data imbalance, and that's why in MORGAN we amplify data density of both closed and open space. Basically, in each episode, we sample support set from the known classes and a query set from a combination of both known and pseudo-unknown classes. We extract corresponding feature vectors. Thereafter, using a low noise variance, we generate pseudo-closed samples, SL, and augment with support features to compute known class prototypes. On the other hand, from a high noise variance, we generate pseudo-open set samples, SH, and we augment with the query features. For each query, we measure the metric distance from known class prototypes, and using an outlier detector binary classifier, we classify whether the query is known or unknown. In case of query is known detected, its category further can be detected by applying shortness over the query distance. However, due to utilizing low noise variance and high noise variance, we might encounter the pseudo-closed and open set samples are quite overlapping with each other. Therefore, we further penalize our pseudo-open sample generator using a novel anti-overlap latent regularizer. Basically, whenever ZL and ZH are sampled very close to each other, anti-overlap latent regularizer penalizes only the pseudo-open sample generator produce SH quite discriminant from SL. And we apply it to minimize our pseudo-open sample generator using LH. We minimize both LL and LH, which is the loss function for the pseudo-closed sample and pseudo-open sample generated using first-order optimization-based method Reptile. To minimize the feature extractor loss, we consider three different loss components. First, we minimize the intra-class variance of each known classes to get balanced representation of known classes. Thereafter, we penalize each outliers to scatter around the metric space from each known classes and gets pulled to a pseudo open space prototype. Outlier calibration loss further penalizes each query to get recognized either as a known or an outlier. In results, Morgan beats existing OSR and FSOSR methods over all the four benchmark HSI datasets for three matrices. You can observe that AURC plot, which is in red in card, which it's beating all the existing methods by a large margin. In case of classification map comparison of hyperspectral datasets, Morgan's outlier detection, which is the white pixels, annotated white pixels, does not produce any false positive, and most of the pseudo-open classes are properly detected. Simultaneously, the closed set samples also are properly recognized, which is not recognized by existing methods. In future, we would like to extend our experiment over unknown geographical region to detect outliers used from a cross dataset experiments. Thank you.